Okay, here we are back for the cosine graph. Y equals cosine of theta. Once again, input is an angle. Output is the cosine value. The cosine value is adjacent over hypotenuse, but it's easier to think of this as the x coordinate on the unit circle. Now, cosine's kind of odd because what I want you to think about here is, if we go back to the unit circle, this is a lot easier when I can point, but hopefully with my cursor, oops, you can see this. What's happening to the cosine value as we move around the unit circle? The cosine value is the x value. So here we have a fairly large x value. Well, actually, here's the very largest x value, 1. Then for the next one, we have an x value of square root of 3 over 2. Then we don't go out as far for the 45, square root of 2 over 2. Then we go out just a short way for 60, 1/2. And then straight up and down, we don't have any x value at all. It's negative. It's a 0. Then when we head into quadrant 2, our x values are negative. Negative 1/2. Negative square root of 2 over 2. Negative square root of 3 over 2. Then back to negative 1. When we're in quadrant 4, cosine values are still negative, but getting smaller, the numbers themselves are getting smaller till cosine is 0. Then cosine switches to positive numbers again in quadrant 1, and the numbers get bigger until we get back up to 1. So whereas, and I think I'm going to have to do this kind of on another little drawing to help illustrate this. So I'm going to kind of go back here. When I'm doing sine values, what's happening with sine, if you can imagine as this point travels around, so I'm going to put the point at different places around the circle. As the point travels around the circle, my y values are getting bigger. Okay, as I go around, my y values are then getting smaller. Then my y values are going to be negative over here. And then they're going to get bigger and bigger until we get down to negative 1. You know, here's my positive 1. Here's 0 and 0. Okay, so if I were to kind of unfold this onto the graph, okay, what's happening with the sine graph is my y values are getting bigger and bigger and bigger. They reach their peak at 90 degrees. We get to 1, okay? And then they get down lower and lower. Then we go into quadrant 3. They get smaller and smaller and smaller and smaller and go back up until we get down, we get down to negative 1 and then back to 0, okay? So, and this is at 270 degrees, it gets down to the negative 1. So the y value on the graph represents the height, or the y value on the unit circle represents the height of the graph here. Now, this is for sine, okay? So this is all for sine. Now, cosine's a little different. So if I do the same kind of drawing for cosine, here's my circle, all right? Draw this, and now I'm looking at different points as we move around the unit circle, different points like this. So I'm measuring the x value. So what does the x value looks like? Well, it starts out 1. Okay, what's happening to my x values? My x distance is getting shorter and shorter until it gets to 0. Then my x distance is negative, but it's getting longer. Okay, it's getting higher until you get to negative 1. So it starts out at positive 1 over here, gets to negative 1. Still negative in quadrant 3, but getting shorter, smaller distances. Then goes to 0. And then we start into positive numbers again, which get bigger and bigger until we get back to 1. Now here's the weird part. When we draw this graph, what's happening on the y-axis for the cosine graph is the horizontal distance on the unit circle. So I start out with this long piece here is my first segment on the y-axis. Then I have shorter and shorter and shorter segments like this. Then it goes into the negative. And I have shorter segments, longer segments like that. So I'm looking at these, the length of my horizontal pieces here, but they're arranged vertically on this graph. And then when I get into quadrant 4, I start out with these short blue pieces, which are above the x-axis now because they're positive, and they get longer and longer and longer. So the cosine graphs looks more like this. Okay, so we're going to draw the cosine graph. Cosine, remember, it represents then how the horizontal distance is changing on the unit circle, whereas sine represents how the vertical distance is changing on the unit circle. Okay, so let's go to the cosine graph and let's plot some of those key points. So at 0 degrees, the horizontal distance is at a maximum. It is at 1. At 360, we're back to that 1. When we get up to 90, the horizontal distance is 0. When we go down to 180, the horizontal distance is at a minimum. The horizontal distance now, or sorry, not down to 180, but when we go to 180 on the unit circle, the horizontal distance is -1. When we're at 270, the horizontal distance is 0. In between, now we have positive values that are going down in quadrant 1, positive values of x, but getting smaller and smaller as we get up to 90. So 30 is square root of 3 over 2, which is almost up to 0.9. 45 is 0.7. 60 is 0.5. So this is in quadrant 1, we're going down. Then we get to quadrant 2, and we're in the negative values. 120 would be -1/2. 225, -0.7. 150, -0.86. Quadrant 3, still negative. -0.86. -0.7, halfway in between 210 and 240. At 240, -5. Then back up to 270. At 300, positive 0.5. 315, halfway between 300 and 330 on the grid, 0.7. 330, 0.86. So the graph looks like it curves down to the x-axis. Under the x-axis, it curves up like that. And then above the x-axis, it curves down again. So the way I describe this is I say cosine is a cup that starts up because it starts high, whereas cosine starts on 0, 0, or sorry, as sine starts on 0, 0, cosine starts at 0, 1. So the key points here are 0, 1, 180, 0. Sorry, that's not 180, 0, that's 90, 0. My mistake. 90, 0. 180, -1. 270, 0. And 360, 1. If we keep going, the graph would repeat itself. So if we go backwards, think about -90 is going to be the same as positive 270, and we're going to be at 0. -180 is going to be the same as positive 180. We'll be down at -1. -270 is the same as positive 90, back to 0. And then -360 is going to be the same as 0 or positive 360. So this graph continues on, curves down. So don't make it pointy. Curves up, curves down. Now, something interesting about cosine that I want to show you. I'm going to trace over the entire cosine graph with a different color. You're going to wish you could do this. It's so cool. Okay, now if I take this whole cosine graph and I shift it to the right 90, guess what? I get the sine graph. So there's the sine graph. The sine graph is the same curve as the cosine graph, it just shifted over 90 degrees. As a matter of fact, I could write this using transformations. I could say sine of theta is equal to cosine of the quantity theta minus 90. Remember, subtracting a number inside the function shifts the graph to the right. So if I put 90 degrees for theta, I would have cosine of 0 equals sine of 90. Well, cosine of 0 is 1, sine of 90 is 1. They equal each other. These are exactly the same curves, just shifted over. Notice where they intersect and they're the same is at 45 degrees, which makes sense because at 45 degrees, I don't think I shifted this maybe quite enough, but at 45 degrees, they have the same, sine and cosine have the same value. They're both square root of 2 over 2. So I'm going to just delete that. That's just a little fun fact that I wanted to show you about this. They are the same curve. Okay, in our next video, then we'll talk about tangent.